Okay, so here's the deal. We got 5-6. We got geometry 5-6 today. We are skipping 5-5. All right, and I want to emphasize the importance of 5-1, 5-2, 5-3, 5-4. They were so important that 5-5 got yanked out of play in order for us to do a review that day. Now, I will post the answers for 5-1, 5-4 review that we did yesterday tonight after school when I get it all ready to rock and roll and put it up there. The answers will be posted, not the solutions. And the reason that that's such a big deal, if you don't have the solutions, I wouldn't hand it in. I won't give you any credit for it. Okay, so just make sure you're aware of that. Today, we have an objective to use inequalities involving angles and sides of triangles. What we're going to be looking at is triangle exterior angle theorem and its corollary, triangle sides and angles and how they are related, triangle inequality, and possible third side length or a range. Okay, and that range is a range of possible values for the third side length of a triangle. Okay, so first of all, let's talk about these two because it's really a connection of something we've done before. And back in, I want to say chapter 3, we did stuff with remote interior angles. So now we've got remote interior and exterior angles. The exterior angle is equal to the two non-adjacent remote interiors. Now, if I add those two angles together, I get the measure of angle 1. Which makes the corollary we're talking about today so significantly interesting. And a corollary is a theorem that they say can follow easily from the original. Okay. Now, the corollary states that the measure of the exterior angle is greater than the measure of each of its remote interiors, which means the measure of angle 1, the exterior angle, that's made by the sum of angle 1 and angle 2 and angle 3, is larger than just angle 2 by itself and is larger than just angle 3 by itself. And that's what they're saying here and here. Okay? And some of it's like, well, yeah, that makes sense as we go through. How will this come up in a test or a quiz? I'll say, hey, in the diagram, which angle, what do you know about angle 1 and angle 2? And angle 1 would be like the exterior angle, and angle 2 will be one of the remote interiors. And your answer will be, well, the measure of angle 1 is greater than the measure of angle 2. Okay? That's what we're going to be showing. So with that idea in mind, looking at the diagram, explain why the measure of angle 1 is greater than the measure of angle 2. And sometimes it's as easy as parroting back a theorem. Done. And people are like, no way. We just learned that. Is that really even possible? I go, yeah, no problem. But after you finish that, look at problem B. Okay? Finish it up, and then look at problem B. Now, looking at problem B, keep in mind those little arrowheads in the middle of a segment, what do those mean? Or middle of a line, I should say. What do those mean comparing those two lines? What's that mean to us? Chapter 3 stuff. It's parallel. Fantastic recall, folks. Really nice. Now, I know those lines are parallel. If this were a transversal, what do I know about angle 2 and angle 3? What type of angle? Say it louder, louder. Fantastic. Alternate interior. So we got alternate interiors. So here's what I know about this. They're asking, hey, what do you know, or how do you know that the measure of angle 1 is greater than the measure of angle 2? Okay, so the measure of angle 1 is greater than the measure of angle 2. How do I know? Well, 2 and 3 are congruent, or equal, I should say, because of alternate interior angles, AIA. And then I know that 1 is greater than 3 because of the corollary of the triangle exterior angle theorem. And I know people are like, Bloom, where did you see the corollary tri-X angle theorem? Okay, and I kind of truncated the corollary of triangle exterior angle theorem because otherwise it wouldn't fit on my page. And then if I use transitive property or substitution, transitive property of equality or substitution, I know that the measurement angle 1 is greater than measurement angle 2. That's how I know that 1's greater than 2, or okay. I just kind of stepped through that just to make sure I didn't like jump over things to explain myself. So I'll give you some time to get that down. Okay, as you finish, kind of read on the next thing. Do a little pre-read on this next theorem if you're done before others. And we'll see what we can do. Now, friendly reminder as this stuff is going on. Your test for chapter 5 is next week. Be ready, okay? Make sure that you're rereading your notes. Make sure that you're asking questions that come up when you do reread those notes, or just put them in the margin and just say, hey, we got to ask Bloom about this, or ask one of us about this. You know, one of us geometry teachers, myself, Gosha, or Moynihan. I don't care which one you get the information from. It works. Okay. So now, as we're going on, my theorem 510 doesn't seem like a real important theorem. It's just numbered, doesn't have a name, but it's one of those theorems that we have to pay attention to. Now, if two sides of a triangle are not congruent, okay, then the larger angle lies opposite the longer side. Because if they were congruent, the angles would be equal, and then therefore the sides should be equal. But keep in mind, if I've got a scalene triangle, okay, and I have angle measures and sides, the larger angle lies opposite the longer side, okay? All right, so I have an example of that, xz, this larger side, because we're talking about that's the larger side than xy, and xy is this one. Inside the triangle, we can actually compare side lengths based on angle values for every triangle, okay? And we kind of already knew that the larger side's opposite the largest angle, or the larger angle's opposite the larger side, because of right triangles. The hypotenuse is the largest side. It's opposite the largest angle, okay? So it's always something that's been there, but no one's ever said it, and now we've said it. We talked about the elephant in the room. But now, one of my concerns is recognizing opposites, okay? The side opposite an angle is the side that does not make the angle in a triangle, okay? And what I mean by that, when I'm looking at this example picture, this theorem picture, is that if I'm talking about angle y, xz had no help in making that angle, but is the side opposite that angle, okay? So keep that in mind, what opposite an angle means. Now, because in order to apply this theorem, it is as easy as recognizing the size of the side given. And people are, what do you mean, the side length? Yeah, look at A. 2.9, 3, 3.1. Which one's the smallest side? People are looking at me like I just asked them a trick question. 2.9, right? So 2.9 is opposite angle B. And we're supposed to list the angles of each triangle in order smallest to largest. Angle B is the smallest because it's opposite the smallest side. So angle B is first. Okay? Now, my next size side, the next up, Mr. Stroud. 3. Okay, great. 3 is opposite angle A. Angle A is the next angle in line. Okay? And then my last one, everybody's like, oh, I hope I get asked because that's it. I got it. Okay, it's the largest side that's left. It's opposite the largest angle. So 3.1 is opposite angle C. It's the largest side. Angle C is the largest angle. Okay, it's that direct. Okay, one thing I want you to make a change of before you do problem B, that 3 has to be 3y. There has I cut off the tail somehow. Apparently it grows back, but you know, just fix it. And now keep in mind, to make them harder looking, I add variables. Okay, Well, if I'm adding variables, people stress out a little bit. Oh, it's not numbers, Bloom. It's like, it's still numbers. Okay? They're related. Matter of fact, if you really have a hard time with it, just put a 1 in for y. Put a 1 in for y. You got 3, 4, 5. Decide which angle is the smallest, the next size up, and the largest. Go. Order it in least the greatest order. Go. Get it done. After you're done, check with your row partner, and then move on and finish the other two. After you're done, check with your row partner, and move on, finish the other two. And I'll start showing them like it's a restaurant trivia contest. And remember, if you put it in a list from left to right, it makes sense. If you put it in the list top to bottom, kind of talk about which one's the shortest, which one's the largest, so the person correcting can know. Okay? So are you okay with B? Are there any questions? Get after C. Go for it. Again, I got 1, I added 0, 2, 1, I added 1, 2, 1, I added 2, 2, because so angle Z is opposite just that, so that's the smallest. So I got angle Z. And then the next smallest is the one I'm adding 1, 2. Should go that way. So that's angle X. And then the next smallest, X plus 2, or the largest I should say, is angle Y. Are you okay with my order and what I'm doing and how I found things? Okay, now's the time to ask, because this is what we're doing today. We're ordering things. Last one. It's a right triangle. I know the largest side is QS. And I could actually find that measure if I so chose, because I know something called Pythagorean theorem. So I've got 12 squared plus 5 squared equals C, and I find that square root, I got 13. It's equal to C, that's 13. Well, 13 is bigger than 12 and 5, so I totally know that 5 is the smallest, so angle Q, then angle S, then angle R. And I'm done. How you doing? Is it making sense? Yes, no, maybe. Now, that's page 1. We got the second page and we done. Okay? So let's see what we got. Because the goal is to get that done in 12 minutes. Now, the next thing is, hey, look, 510 was just numbers. It was relationship. 511 is the same idea. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Longer side lies opposite the longer. Hey, that's just the converse of what we just did. They're converses of each other. Crazy. Are you surprised that we have a property and then we learn about that property's converse? I mean, that's pretty much what we've been doing the whole year since we did chapter 2, working with converses. So the hardest thing on this stuff that we're going to do today is realize that if I have a triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C is all equal to 180 to help us do this problem. Okay? Do you remember triangle sum theorem? That's just a review because I'm going to use it there, I'm going to use it there to get things done. And I'm going to use it a couple more times to finish out the worksheet, okay, or the notes today. But triangle sum theorem. In a triangle, I got 44 and 46, that makes 90. This triangle must be right because those two are 90 together, so the last one's got to be 90 itself. Now that I know that that's 90, please list the sides in order. Please list the sides in order, shortest to longest. I'm telling you that the hardest thing right now after you learn this method to do this is paying attention to the order you're asked to put things in the question, because they can reverse it. Largest to smallest. Okay, so order it, get it done, see what you know. How you doing? Are there questions? Now remember, if you're writing down the stuff I've got and you didn't try, you either have a question or you're just not here totally today. Make sure you get with it and start doing it on your own, because we're checking your work to see how you get it. If you get it, you should be able to do it on your own. If you're not getting it, you should be asking questions today. Because remember, today and tomorrow, the last 2 days of new material. Okay? Test is Wednesday next week. You got 2 more days of review and then you got the test. Make sure you get the new material understood, because ideally 5-1, 5-2, 5-3, 5-4, we're talking about medians, mid-segments of triangles, angle bisector, perpendicular bisector, centroid, in-center, circumcenter, centroid. That's all covered. All that stuff is in there. Oh, I forgot orthocenter. Okay, so make sure you know all those things as we're going through. Okay. Now, this next one, I got 54 of 61. Gosh, it looks like 65 is missing. Okay, so I've got a 65 going on there. And now I make the determination of which side is bigger and which side is the next, smallest. And I got to start at the small one. So sides are directly related to angle measure. Angle's 54, that's the smallest angle, smallest side's MO. Next smallest side, the middle size, 61, NO. Last one, across from 65, MN. Are there questions? Now I'm going to let you in on a little secret when we're doing this. If I've got the smallest angle at Q, and I know this is triangle QRS. That's the smallest, and the smallest angle is Q. The other 2 angles make my side that's opposite RS. And that was weird, that was small. Okay, if I got my next size angle, 46, as S, then the side opposite must be QR. Check it out, weird. Boom said it's QR. My largest angle, which is R, the side opposite that is QS. Okay, and I point this out because you can actually do this because there's only 3 points in a triangle, and the one point they give you an angle measure, and you get to determine that the other 2 points are the side opposite it. So you can do this without having a diagram. Try doing this without a diagram. Locate the smallest angle in triangle ABC. The other 2 letters that aren't the smallest angle make up the side opposite the smallest angle. So C is the smallest angle. What's the side opposite it? You okay with AB? That's the smallest side. The next size angle is B. So AC is opposite that. The next one's A, so BC is opposite that. And our order should be ABC, ACB. Done. Okay, now, I've got some folks that aren't there yet. There are still going, Bloom, that was like mysticism. I'm okay. Go ahead. Put in that diagram. Pop in your numbers. Do it that way. But I want you to be aware, ACT, SAT, MCA, all make problems harder by leaving the jargon in the problem and not giving you a diagram. They won't give you a diagram. They expect you to know from the vocabulary and the information provided how to do it. Okay, with no diagram whatsoever. Okay? Now, this comparing side stuff and angles. Try do it. Hey, look, Bloom didn't leave us a diagram. Oh, he must be trying the harder questions. So go ahead, fill those in. need a diagram, go ahead and draw it, but try it without the diagram and then do it with the diagram to check to see if you start getting understanding of the connection there. So remember, list the angles of each triangle in order from smallest to largest. So that means if I go to the smallest side, the smallest angle is the angle opposite that side, and in this case, it's the letter that's not making the smallest side. Smallest side is 13, AC. The letter that doesn't make it, angle B. Angle B should be the smallest angle. That's opposite the smallest side. I look at the next side, AB. C's not in there, so it should be angle C. I look at the next one. The largest side is BC, 29. Angle A must be the largest angle, angle A. Now, keep in mind, as we're looking at this, the purpose of what we just did was to make things faster in a test that's timed. But it's only good if we understand how it works and we use it correctly. So let's double check our work. I've got A, B, C, okay? And AC was 13, BC was 29, AB was 17. Now keep in mind, I don't care about drawing a segment to scale. I'm just trying to set it up so I get what's happening. B is across from the smallest side. Hey, we said that. Okay. The next size was C. Now it's across. Hey, we said that. And A. Oh, hey, totally works. Okay. So you see where I'm going with this? So hopefully you start recognizing that connection, that pattern. Okay. So I go to the smallest side, MN, and it's MNO. So O's got to be the smallest angle. And I go to the largest side, NO. So M's got to be the largest. O and M and N in between. Got it done. Okay? Are you okay with what I'm doing here? Now, please keep in mind, you should have an answer that you're looking for in a multiple choice test. Okay, as opposed to looking at their answers and determining if they're right. There's a difference. If you're looking for the order that you set up, it's easier to find the answer. If you're looking at their answer that they set up, remember, though, the first 3 most popular right answers are they're accompanying the right answer. And I always get a kick out of students who go, well, you know, I found all the answers I was looking for. You're supposed to. You're supposed to find the answer you're looking for, because in a multiple choice test, the top 4 answers are on the board all the time. Okay? If you found something that's not there, you did something creatively unique. Okay? You're not in the top 4. So just keep that in mind as we're going. Now, let's talk about an application of this. I can't today compare triangles, side lengths, or angles across 2 different triangles unless they are connected somehow, because it's a relative size. Okay, it's not an absolute thing. Okay, so when I'm doing this, I've got to realize that this is me looking at triangles that have connections. So first, I got 59 and I've got 60 for these missing angles that I've got to deal with. Okay, I'm going to work inside this triangle first. Okay, and people are like, well, why did you choose that? It's on the left, and I've been practicing with one triangle. We've been ordering, so I'm going to order the sides shortest, the greatest, and then I'm going to determine which one's the smallest in the diagram. So if I look at this, 59 is opposite DC, so I got DC. 60 is opposite AD, so I got AD. And 61 is opposite AC, so now I got AC. Now I go to the other triangle. Let's call this my green triangle. And 55 is the smallest angle over here. And some students right now are going, why didn't you start with that, Bloom? Well, let's look at this. 55 in the green triangle is the smallest, you know, across from the smallest side, right? Because 55 is the smallest angle. In the red triangle, it's the largest side, relatively speaking. So it's AC. And then I go to 60, which is across from BC. And then I go to AB. Okay, well, AB is my largest. This is my smallest. Okay, that's what they asked me to find, or shortest side, and I got it done. but I had to have a comparison. And everybody always asks, why did you start there? I like working left to right. Okay, that way I cover and make sure I find them all. Okay, and people are like, well, there aren't 6 segments you have there, Bloom. And it's like, that's right, because I have overlapping triangles. They share a side. So there should only be 5 I'm comparing, okay, as I go through. It's your turn. You guys try B. Your turn. Try B. Folks are doing a great job. We got about 4 minutes left, 6 minutes left. Notes after this. Now I got my 2 angles I should have found using triangle sum theorem. And now I start evaluating. At DG, that's across from 52. ED is across from 61. EG is across from 67. But EG 67, that's across from the 47. The 47, that's the smallest. That's crazy in this other one. So I got to be careful. This is EG, it's the smallest, and then I go to 48 is FG, and then I go EF. And so now I got shortest. I'll actually use what the word they wanted me to use initially, shortest. Okay, are you okay with what I'm doing and how I'm ordering them? Questions? We're doing good? Now, today we're going to look at the triangle inequality. We're also going to look at it tomorrow. Today I'm using numbers. Tomorrow I'll use algebraic sentences. Okay, and you'll be like, what? So we'll explain that tomorrow. For right now today, you need to know for a triangle, or I should say for 3 measures to make a triangle, 2 of the measures must add together be larger than the other measure that's in that grouping. So what I always say to students is like, hey, well, if I have 2 sides bigger than the other, and this 2 sides bigger than the other, and 2 sides, when I add them together, is bigger than the other, then it makes a triangle. But I always tell students that there's a shortcut, okay? And people are like, no way, there's no shortcut, Bloom. That's just the way it is. This can be painful for us to get this done. Okay, let's talk about it. If I have 8, 7, and 9, could it possibly make a triangle? According to the triangle inequality theorem, it requires us to compare 2 sides to the 3rd side when I add them. So I go 8 plus 7 greater than 9, 7 plus 9 greater than 8, 9 plus 8 greater than 7. Every one of them's got to be true for me to say, okay, it makes a triangle. Okay, yes, it's a triangle. Totally works. The sum of 2 sides is always bigger than the 3rd side. Now, I want you guys to try doing this. Add 7 and 13, is that greater than 6? Add 13 and 6, is that greater than 7? Add 6 and 7, is that greater than 13? Consider all 3 of those. Write them down. And then think about it. Does it meet the triangle inequality theorem? Ideas, thoughts. What do you know? Do you think it's a trick question? People are, trick? No smoke, no mirror trick. It's not one of those. I'm not a magician. Okay? I'm a mathematician. Mathematician, maybe. Okay? So here's the deal. Totally works. Totally works. Are you kidding me? Right? Because 6 plus 7 is 13. It's not greater than. Okay? Not a triangle. Not a triangle. Now, what I need you to know is that if it's ever going to fail, it's always going to fail when you take the 2 smallest sides and add them together to be bigger than the largest side. So that's the Bloom shortcut. Sum of the smallest 2's got to be greater than the largest. Just go straight to it. Okay? Sum of the smallest 2 got to be greater than the largest. If they are, it's going to be a triangle. If they're not going to be. Okay? Do C and D using the shortcut. Again, my job is to show you, to inform you, but to also assist you in being fast. And the show and inform happens every day, but the assist of being fast, okay, that happens with your experience. The more you know about a material, the easier it is to understand the shortcuts. So make sure you're rereading these. Make sure you're rereading your notes. Make sure you're recognizing the shortcut. Make sure you write in the shortcut recognition, because these last two are just that fast. That's it. Go to the smallest two. Do they add together to be bigger than the largest? Not equal to. Can't be equal to. It's got to be bigger. Okay? Now, my last thing. And I've got it up on the board over here again. Possible third side length. It should be a range of values. Okay? It will turn its ugly head in the test and which of the following choices is possible third side for a triangle length, you know, given that the first two sides of a triangle are whatever and whatever, okay? But we got to understand some stuff about triangles. So let's understand some stuff about triangles. I want you to look at this. In problem A, you got 5 and 11. So the two extremes on 5 and 11 is either 5 and 11 have the same vertex, and 5 is really close. The end of 5 is really close to the end of 11 vertex, which is 6 away. Okay? Wow, we didn't want to do that. Let's undo that. Okay? The other thing is maybe 5 and 11 are extremes, and it's now at the endpoints are 16 away. These are my two extremes. Okay? The third side has to be between these two values. Okay? And students are like, well, okay, that makes sense. And so when I start talking about this, I'm talking about the fact that I've got to find the difference and the sum of the values that I'm provided to find my range of possible answers of the third side. Okay? Because I know it's got to be greater than 6, but also less than 16. So 6 is less than x, which is less than 16, where x is the possible third side. Okay? Are you okay with what I did? And my reasoning for why? Because those last three are yours to get after. You're really doing oh, by the way, it's always a positive value, your results. So when you find yourself subtracting them and it's negative, just take its absolute value. Okay? So go ahead, get after it. Answer those three. Compare with your row partners as I'm handing out your assignment today. Now, as far as today's assignment's concerned, assignments are there to solidify short-term memory to long-term memory, to bring it in. And when we go through notes, it's all in short-term memory. So now, without referring to your notes, try to come up with the solutions of these. And then, as you get caught up or stuck, then refer to your notes. And use your notes as a reference. But try to do them first without them. And thank you for your time. Make sure you're getting it done. Remember, your solutions for the review 5.1 to 5.4 will be posted, so you can check that, and we can just go over questions tomorrow.